So in this video, we can have to discuss about the derivative of the exponential functions with base e. So mind you, we have two forms of the exponential functions. We have that of y is equal to a to the power x, where this is the exponential function with a constant base other than e. And we have another exponential function with the actually which is given as y is equal to e to the power x, where this is the exponential function with base e. So I'd like to see on how can be able to differentiate those exponential functions with base e. So let's say we have the exponential function. Let's say y is equal to e to the power u. So what is the derivative of this function? So now the general formula states that the y prime is given as e to the power u times the derivative of the actual power, which means the same function times the derivative of the power. So that's the general form. And let's say we have, and that should be, let's say have y is equal to, let's say e to the power x. So what is the derivative of this function? So now principle remains the same. This is the exponential function with base e. We'll have it as u is equal to x, and the u prime is given as 1. Therefore have it as y prime is equal, now should be e to the power u times u prime, which should be given as e to the power x times 1, which is the same as e to the power x. So that is the derivative. And let's say we have this case now. Let's say we have y is equal to e to the power, let's say, cos x. So what is the derivative of this function? So now this is the exponential function with base e as well. So now have the power being given as cos x, and the u prime is given as the negative sin x, because the derivative of cos x is given as the negative x. So now which means we'll have it as y prime is equal to e to the power cos x, and the times negative a sin x. So which is the same as negative a sin x e to the power cos x. So that's the derivative of that function. And what if we have this case? Let's say have it in this way, and say we have, let's say y is equal to e to the power 2 rin x. So what is the derivative of this function? So now principle remains the same. This is the exponential function with the base e. So have the power being given as 2 rin x. So what is the derivative of that one? Now this is the natural log function. That will be given as a 2 times 1 over x, because the derivative of the rin x is given as 1 over x. Now have it as 2 over x. So have it as y prime is equal to e to the power 2 rin x times 2 over should be x. Now which is the same as 2. Now which is the same as 2. Now should be to the power 2 rin x now over x. So that is the same as that. And what if you have this case now? Let's say have y is equal to 5 e to the power, let's say, sec x. So what is the derivative of this function? Mind you, this is actually a coefficient. So now we'll have to differentiate this part and then multiply the result by that one. Of course, some people tend to use the product rule. It works as well, but you know, it is tiresome. Just have to skip that one out, differentiate this one, then you have to multiply that one by that one. It is the same. So feel free to have that one using the product rule. It will give you the same way. Anyways, now we have u being given as sec x. The u prime is given as a sec x, and actually tan x, because the derivative of sec x is given as the sec x times tan x. So y prime will be given as a 5 e to the power a sec x times now sec x tan x. So that is the derivative of that function. So in other words, the same function times the derivative of the power. That's the essence behind. Now what if we have this case now? Let's say have y is equal to, let's say rin e to the power, let's say cos x squared. So what is the derivative of this function? Now this is the actually this is now the natural log function. What is the principle behind? It is this that the y prime is given as should be u prime over u, where u is the inner function and the u prime is the derivative of the inner function for the actual natural log function. And should it be that you missed out and just have to go through and check in multiple channel, come across the derivative of the natural log functions. You come across that. But now the u is given us, in this case, is given us e to the power cos x squared. Now what is the derivative of this one? So now we have the exponential function with the base e. Now have it as u prime is equal to, now we need to be very careful with the notation that you have to use. Let's think of using it as, now let's think of using it as e to the power v times the v prime. It will be okay because here we have it as u prime as well as the u. Now if we say this is the u as well, we'll have to we'll bring about the confusions. So have that understand. So what is the v? We have it as cos x squared. Now what is the v prime? We'll have it as now a chain law. We have a cos, which is the outer function, and x squared, which is the inner function. So have it as negative a sine x squared times the derivative of the inner function, which is given as 2x. So which means we have it as negative 2x and that of sine x squared. So now have the u prime, that will be given as e to the power cos x squared times a negative 2x a sine x squared. That is the same as negative 2x should be a sine x squared and e to the power cos x squared. So that is the u prime. Then I'll have to substitute in that one. And we should have it in this case. So now have y prime being given as u prime, which is given as 2x sine x squared e to the power cos x squared, and divide by the u, which is given as e to the power should be now cos x squared. And of which you see that this and this will have to cancel. Now have it as this case. So that is the derivative. So take note of that, the way we are having such stuffs. And also think about this one as well. What if we have, let's say, in this case, let's say y is equal to, and that should be e to the power, let's say, x squared, and the times the square root of, let's say, x minus 7. So it should be that. So what is the derivative of this function? Now this is the exponential function with the base e. So the principle behind it says that we'll have it as u is equal to, now x squared times the square root of x plus 7, of which this is the same as having it as x squared and that times x plus 7 and that with the power half. So what is the u prime? So now I'm going to use the product rule, where I'll have f of x a prime times g of x plus g of x prime times f. Just have to refer to the video I explained about the product rule. You come across all these things in case you missed it. So what is f of x? We'll have it as x squared. And what is f of x prime? We'll have it as 2x. And what is g of x? We'll have it as x plus 7 to the power half. And what is g of x prime? So now I'm going to use the chain rule there. That will be given as a half, that is the derivative of the other function, times the derivative of the inner function, which is given as 1. So which means we'll have it as in this case we'll have it as should be 1 over 2 times the square root of x plus 7. So this is according to the laws of indices, though you have done it there. So now which means we'll have it as, in this case, so now what should be this? What's happening? So now we'll have it in this case now. So have it as y prime is equal to, now have to substitute. Let's have it in this way. Let me just have to have it in this case. Let's now have the y prime that will be given as, now have it as the same function, and which is x squared and the square root of x plus 7 times the derivative of the power, which is the derivative of this one, and that we got it as, of course we'll have to substitute for u prime first before we do anything. So what is the u prime? We have to substitute because it was under the product rule. So now u prime will not be given us, we'll have to substitute what is this and also what is this. Afterwards we'll have to substitute into this formula, and that will be given as the y prime is equal to e to the power u times the u prime. So try to have that and out and substitute it in that way. Now what if I have this case and say we have it as, let's say y is equal to ln, let's say, and that should be 1 plus e to the power x divided by, let's say, 1 should be minus e to the power x. Let's say that's the case in this nature. So should be the case. So what is the derivative of this function? So we use the actual, this is the natural function. Now according to the principle behind, we have it as y prime is equal to u prime over u. That is the way to go. So now which means, what is the u? We have it as 1 plus e to the power x over 1 minus e to the power x. So what is the derivative of that? And we use the quotient rule. So try to have the quotient rule and try to have the solution of that problem in that way. I understand you know what is the quotient rule, and should it be that you missed that one, just have to go through the video we discussed about that one. So just have to check it on the YouTube channel bearing the name of a channel, or else you have to have that one from whichever the source of interest you can have to. You'll be able to have that one out. Let's say you have e to the power negative t, and let's say plus e to the power t, and over to the power 5. So what is the derivative of this function? So now we're going to use the chain rule, which is this, that the y prime is given as n g of x n minus 1 times g of x prime. That is the formula for the chain rule, of which we have the inner function given as should be now g of t, since the function is of t. So it varies. If you feel okay to use this formula, it is okay, but you know, I just prefer that the derivative of that outer function times the derivative of the inner function. But sometimes you may come across some problems that are very complicated, that will require you to have the procedures. So now have g of t. G of t is given as e to the power negative t and the plus e to the power positive t. What is the prime? We'll have it as now negative e to the power negative t plus e to the power t, because the derivative of this one will be the same as will be this one. So have that. So now which means the y prime will be given as, now have 5 should be e to the power negative t and plus e to the power positive t, and that times 4 times now e to the power actually negative e to the power negative t and plus e to the power t. So you'll be able to multiply this one, that will be the solution. And also think about this one as well and see the way you can have to deal it out. Let's say we have this case. Let's say we have y is equal to e to the power, let's say, negative 5 over 4. So what is the derivative of this function? Now should be this. Let me probably orient the problem. So I'll have it as negative a 5 over 4 should be over 4. Now should be this. Should be over 14. Let's say that's the case. So now, which means this is the exponential function with the base e. So now I'll have it as the u being given as negative 5 over 40, of which this is the same as negative 5 over 4 and the 1 over t. That is the same as negative 5 over 4 and a t to the power negative 1. So what is the u prime? Now have it as negative 5 over 4 times negative a t to the power negative 2. That is the same as positive 5 over 4 and a t to the power negative 2, of which that is the same as 5 over 4 and that should be 80 square. That is. So now which means we'll have the y prime being given as e to the power negative 5 over 4t and the times that one. So take note of that. You should have to get it in that way. And also think about this one as well. The way you should have to understand these things. Now, what if you have this case? Let's say have y is equal to, and that should be cos x to the power 5 and let's say plus let's say e. Now sine should be this. Now should be e to the power 5x further. Actually it should be that. Let's just be this. Now we have e sine, let's say, a square of e to the power, let's say, negative 2x. Let's say that's the case. So what is the derivative of this function? So we have somewhere where I need to rewrite the expression, which is this part. So now which means we'll have y being given as cos e to the power x and the plus e sine and now e to the power negative 2x and the terms actually half. That's what it means there. So which means we'll have this one and that one being cancelled. Now have y is equal cos e to the power x and the plus e sine e to the power negative x. That's what it means there. So now we're going to have to differentiate the function. So in the sense that we'll have y prime is equal to, what is this one? We're going to use the chain rule. We'll have the outer function times the derivative of the inner function. So what is the outer function? We'll have negative sine x should be sine e to the power x times the derivative of the inner function, which is e to the power x, and the plus. Now just have this e, it means it's a constant. So it is like though you can have, let's say, 2 sine whatever. So it is the same as that. So which means we'll have it as and e. Now have to differentiate this part using the chain rule. So have it as in this case. So have cos e to the power negative x times the derivative of the power, which is negative 1. So which means we'll have it as negative a sine e to the power x. Now should have this one as this. Let me have it in this way. Mind you, you cannot multiply these two. They're different. So now have negative e to the power x and sine e to the power x and minus now e cos e to the power negative x. So that is the derivative of the function in that way. Now you have to be much aware about that one. What if we have, let's say, y is equal to ln e to the power x to the power 4? What is that one? So now this is the natural function, where the inner function is the exponential function at the base e. So try that one out at your own time. You should have it. Now, what if now we should have to come up with the equation of a tangent line to a curve of, let's say, a y is equal to, and that should be now x to the power 4 and e to the power, let's say, 2x at a point given as, let's say, that should be, let's say, 0, 1. So what is that one? So first thing, you have to differentiate a function. We're going to use the actual product rule here. And then you do what we've been discussing about. So try to have an equation there. So try to have that at one end. But I should just have to tell you something here. And that should be that. But it is okay. Try to have that and out. It will be right. You manage it. You manage it light. You know, I don't think that you feel that one. You know, such simple equation to look up to. You can make it easier. So those are some of the things you have to understand about actually the derivative of the exponential function with the base e. But let me help you with this question. Let's say you have y is equal to e to the power, let's say, negative x squared. Should be negative 2x squared, rather. Negative 2x squared. That should be negative 2x squared. And let's say, should be just x, not x squared. And now plus x squared. We should have to evaluate the tangent line at a point 2, 1. Where is that one? So I guess you can have to manage that one out. So try that one as well. I don't think I can help you that one. It is a very simple question. Let's say I have y is equal to ln, let's say, e to the power x in the plus. That should be e to the power negative x. This is also another simple question you should have to go through. Now have it as over 2. So we should have to evaluate the actual equation of a tangent line at the point 0, 0. Also try that one out. You manage a case. And also think about this one as well. Let's say have y is equal to, and that should be e to the power negative x. And also, in this case, it should be this. That should be ln x. And ln x. So what's that? At a point given as, let's say, 1, 0. Also try to have the actually equation of a tangent line for this function at this point. So that's how you have to understand about how we differentiate the exponential functions with base e.